Matter present in our surrounding can be classified as pure substances and mixtures. A mixture is a combination of two or more substances which are not chemically the same and do not chemically react together. A mixture has the same properties as that of its component elements and can be separated by physical means. In a mixture of sugar and sand, even if we increase the volume of sugar or sand, the mixture remains the same. So it implies that in a mixture the components can be present in any proportions. When we dissolve common salt in a glass of water, we will obtain salt solution. Similarly, put some mud in a glass containing water and stir it well. We will obtain a mixture with the solid particles of mud dispersed in water. By carefully observing, you will find that in common salt solution, no salt particles settle down to the bottom of the glass. But in the glass containing muddy water, some solid particles settle down to the bottom of the glass. This explains that mixtures have different compositions. Accordingly, mixtures can be classified as homogeneous and heterogeneous. A homogeneous mixture has the same uniform appearance and composition throughout. Many homogeneous mixtures are commonly referred to as solutions. A solution is a mixture of two or more substances in a single phase. The substance in the largest amount is called solvent and the substance in the smallest amount is called solute. Now, consider the case of the common salt solution we have prepared. Here, water is the solvent and salt is the solute. Homogeneous solutions are classified as different types based on the solvent and the solute. 1. Liquid in liquid solution. 2. Solid in liquid solution. 3. Gas in liquid solution. In a solution of vinegar in water, both the solvent and solute are liquids. Hence, it is a liquid in liquid solution. In the case of common salt solution, it is a solid in liquid solution. The best example of gas in liquid solution is soda water. Soda water contains carbon dioxide gas. Let's understand heterogeneous solutions. Suspensions and colloids are heterogeneous mixtures. A suspension is a mixture of large particles. The size of the particles in a suspension is of the order of 10 to the power of -5 centimeters or larger. In a suspension, the solute particles do not dissolve, but they are suspended throughout the solvent. The muddy water which we prepared is a suspension. Colloids are also heterogeneous mixtures, but they appear like a homogeneous mixture. Milk is a good example of colloids. The particle size in colloids is smaller than 10 to the power of -5 centimeters. In colloids, the particles are uniformly distributed throughout the solution. Colloidal particles cannot be seen with the naked eye because of their small size, but their presence can be observed with the help of an ultramicroscope or an electron microscope. What is the effect of light in homogeneous and heterogeneous mixtures? Let us understand how light affects a colloidal solution. When egg albumin is taken in a glass beaker and some water is added to it, we get a colloidal solution of egg albumin. If we were to shine a beam of light from a torch through the beaker, the light is scattered by the colloidal particles and the path of light can therefore be observed. The light scattering effect shown by particles in a colloid was first explained by the British physicist John Tyndall. The effect is known as the Tyndall effect. In the case of a suspension, light does not pass through it. In a true solution of salt in water, we will not see the path of light as there is little scattering of light. Things to remember. Mixtures are composed of variable proportions of different substances without chemical bonding and have the same properties as that of its component elements. Homogeneous mixtures have the same uniform composition and appearance throughout, whereas heterogeneous mixtures consist of visibly different substances or phases. A solution is a homogeneous mixture of two or more substances and the substance present in the largest amount is called solvent, and that present in the smallest amount is called the solute. Suspensions are a heterogeneous mixture of large particles on the order of 10 to the power of -5, in which the solute particles are suspended throughout the solvent. Colloids are heterogeneous mixtures in which the particles are uniformly distributed throughout the solution and the particle size is smaller than 10 to the power of -5 centimeters. The light scattering effect shown by particles in a colloid is known as Tyndall effect.
We're going to take a look at mixtures and solutions today. What is a mixture? A mixture is two or more substances that are added together and each substance still retains or has its own properties. The two substances aren't mixing together creating one unified thing. You can actually see the differences in them. The example that I usually give is peas and carrots. When you look at peas and carrots, you have peas and carrots. You can take the peas out of the carrots and you take the carrots out of the peas. They still have their own properties. What is a solution? A solution can exist in any state. It can be a solid. Brass is a solid solution. It's an alloy of copper and zinc, such as this trumpet that we have right here. It can also be a liquid. Sugar water is a liquid solution. It's a mixture of sugar and water. And gas. Gas is a gaseous solution. Air is. And air is a homogeneous solution of nitrogen, oxygen, and carbon dioxide. They all go together to form the gas solution that we breathe in. Comparing a mixture and solution. A mixture, if you look at this diagram here, we have sand plus water. When you put the sand in the water, as you notice down at the bottom, you have sand in the water at the bottom. They're going to separate by filtering. You could pour it through a coffee filter or any type of filtering device, and it will take the sand out of the water, and all you'll be left with is water. Over on our other side, we have a solution. We have sugar, and we add it to water. The sugar will dissolve in the water. The sugar particles are evenly distributed throughout the water, so you don't see the sugar hanging around in the water. It all becomes one solution. That's the difference between a mixture and a solution. A mixture, you can still see the components and the different substances, and you can take them apart easily. A solution, they mix together and form a unified substance that you cannot easily tell what part is which part. So let's take a look at solutions really quickly. Flavored drinks such as Kool-Aid, that is a solution. You take the package, you dump it in, put it with some water, and the water takes on the color of the Kool-Aid, so it is a solution. Chocolate milk is another one. You put the chocolate syrup in, and of course your white milk turns brown because you added chocolate. And cement. Cement is something that you probably didn't think much about because you can see the rocks and things in it, but you also have sand and water and other chemicals that go into it that dissolve in that water when you make that cement. So you don't always see it. You have a mixture and solution at the same time. So what makes these solutions? What makes them solutions is the fact that we have those two or more substances that are added together that are evenly distributed throughout the solvent so that you don't see the different pieces. I hope this helps you understand mixtures and solutions a little bit better and keep that science hat on.
Sedimentation, decantation, and filtration. In this module, you will learn to separate mud from muddy water by sedimentation and separation of clean water by decantation and filtration. How to get clean drinking water from this muddy water? Well, we shall use few methods to separate the mud from this water-mud mixture. For this activity, we need 2 beakers, a sample of muddy water, a tea strainer, a piece of cloth, funnel, and filter paper. When the heavier component in a mixture settles, the process is called sedimentation. After sedimentation, the process of removal of water above the sediment is called decantation. Separation of finer impurities from the decantate using a filter paper is known as filtration. Take some muddy water in a beaker. It is a mixture of soil and water. Stir this mixture well and leave to settle for half an hour. The mud settles down at the bottom of the beaker by the process of sedimentation. Now, transfer the water at the top of the settled mud by tilting the beaker to another empty, clean beaker. The water thus obtained is called decantate. As the next step, pour the decantate through a tea strainer. This is called filtering. Is it possible to get the clean water after filtering the decantate with the tea strainer? No, the tea strainer is not able to filter the fine particles as you see the filtrate. It is not clear and contains mud. See, the water obtained is to be filtered with a fine cloth. Some mud has deposited on the cloth, but the water obtained after filtration still contains mud. A filter paper which can separate the fine particles of mud from the water. A filter paper has smaller pores than cloth and hence can be used for this purpose. Place the filter paper in the funnel and pour the water obtained after filtration with cloth. Look at the filter paper after filtration. You can see that fine particles of mud are deposited on the filter paper and the filtrate obtained is free from impurity. In this module, you have learnt that when the heavier component in a mixture settles, the process is called sedimentation. The process of removal of water above the sediment is called decantation. Separation of finer impurities from the decantate using a filter paper is known as filtration. The use of a filter paper is a better choice for effective filtration as it has small pores.